All right, so we've covered how to do polynomial long division, okay? Long division is a method that always works. You can always do long division with polynomials. However, as the name implies, it's rather long, okay? So what we're gonna look at today is something called synthetic division. So synthetic division is like a shortcut method of doing division, but it only works in certain situations, okay? So it's like a cheating method. It's kind of cool. We call it synthetic division because it's not really like you don't really do any division to figure this out, which is it's kind of neat. So anyway, so we're going to look at synthetic division. All right, but the first thing that you need to know is that synthetic division only works when you're dividing by a binomial, and it has to be of the form x minus a. Okay, so it only works if you're dividing by a binomial, and it has to be just an x minus a number. Okay, so again, notice that this minus is built in, right? That's showing up a lot in this algebra class, but the minus is built in, so that means we're going to pull that a out, and it'll look like a sign change, but it won't be. Okay. Now, there is a cheating method that we can do. We're going to look at some problems down here where it's like a 2x or a 3x, which is not in this form. So we're going to kind of do a little workaround for that. But in order to actually do synthetic division, it has to be set up in this format. Okay. All right. Now, one extra thing that you should be aware of is there is something called the factor theorem, okay, which says that a polynomial f of x has a factor x minus k if and only if f of k equals 0. The heck does that mean? Okay, it means that when you solve a polynomial, right, you get whatever your solution is, that when you plug that number back into the polynomial, you should get 0 as an answer. Okay, and that should make sense to you, right? Because this whole time when we've been solving polynomials, like when we solved quadratics and we had something like x squared plus 6x plus 9 equals 0, we did a bunch of work. We solved this and we got x equals -3. Okay, so all that this is saying is it's saying that x minus -3, so x minus -3 or x plus 3, right? This is a factor of this polynomial if and only if when you plug this number into your equation, you get 0 as an answer. Okay, so that's all that this is saying, and that should sort of make sense. Okay, so we're going to use that to kind of help us out a little bit here. All right, so let's take a look at an example of how synthetic division works. So the first thing that you're going to do is you're going to take all of the coefficients from this polynomial, and you're just going to write them in order, including, just like we did in long division, zeros for any missing terms. Okay, it is absolutely essential that you put these zeros in when you have a missing term. So like this guy, we're missing an x term, so I'm going to add in a 0x. Okay, so the first thing that I'm doing is I'm writing out these coefficients in order. So -1, and then 4, and then 0, and then 9. Okay, so those are my coefficients. And I'm going to set up a little bar here. Give yourself some room because we're going to write numbers in here. So we're going to have numbers here, and below. Okay, so that goes there. Then what we're going to do is we are going to take whatever your a value is and write that out here on the left. Okay, but be careful because the minus is built in, right? So this is x minus 3. That means that a is +3. Okay, or you can just think of it as it's the opposite sign. Okay, so this number is coming here. Okay, so then what we're going to do, all right, this is a little bit weird. All right, here's what the process is. You start by just bringing down the first number. So the -1 just gets brought down. Then I'm going to multiply the number on the outside with the number on the bottom and write it here. So 3 times -1 is -3. Okay, so I multiplied that and wrote that there. And then I'm going to add those together. So 4 plus -3 is 1. Okay, and then we do the same thing. 3 times 1 is 3. And then add up and down. 0 plus 3 is 3. And then do the same thing. 3 times 3 is 9. And then add up and down 18. Okay, so that's the cheating method. Okay, so we didn't actually do any division, and yet we've divided. Okay, so that's why it's called synthetic division. So great, what on earth do we have here? Okay, so when I look at this, what this gives me is these numbers right here. Okay, these are the coefficients. Okay, so that's the coefficients of your quotient. Okay, and this number at the end is your remainder. Okay, so the last one's your remainder, and the rest of them are the coefficients of your quotient. Okay, so my actual answer for this guy, okay, so my answer is we're going to have here, but we're going to drop the exponent by 1. I started with x to the cube, and I'm dividing it or I'm just doing x to the third divided by something with an x. So you're going to end up with something x squared, right? So it's going to be negative 1x squared plus 1x plus 3. And then my remainder is 18. So just like with long division, I'm going to write this as a fraction. So plus 18 over the thing I was dividing by, x minus 3. And that's my answer. Okay, so that's synthetic division. So it's nice. It's really fast and easy. Okay, so let's do that again with this next one. So this next guy, first thing I'm checking for is, do I have any missing terms? No, not this time. Great. Okay, so then I'm going to start by writing my coefficients. So 3, -2, 2, -5. And there's my little bar thing. I'm dividing by x plus 1. Okay, so it's going to end up being the opposite sign. So this is going to be a -1. So this comes from here, right? And you just got to kind of remember that this was the opposite sign, right? And same thing here. This guy was kind of the opposite sign. It's because the minus is built in, but I think it's easier to remember that it's just the opposite sign. All right, so then what this pattern is you start by just bringing the first number down. So the 3 just comes down. And then -1 times 3 is -3. Okay, and then I add those together, that's -5. -1 times -5 is +5. Add up and down. -1 times 7 is -7. Add up and down. Okay, and this guy is your remainder. Great, okay, so then my answer for this problem, right? Drop the exponent by 1. I started with an x to the third, so this is going to be 3x squared minus 5x plus 7, and then plus my remainder over the thing I was dividing by. All right, with this one, you could have also written minus 12 over x plus 1. Either way is fine, and I would take either. Okay? All right, so just one more time, just to reiterate, right? These guys right here are your coefficients. Okay, so those are your coefficients. This number comes from what you're dividing by, but it's the opposite sign. And then your pattern, you bring the first one down, multiply, add, multiply, add, multiply, add. Last number is your remainder. These are the coefficients of your answer. So it's kind of cool. It's a nice little shortcut that you can use. Okay. All right, so let's take a look at these guys. So we said that it has to be in the form x minus a, but these guys are binomials, but they have a number in front of the x. Okay, so here's the little cheat that we're going to do to get around this issue. Okay, what I'm going to do is I'm actually going to break this into 2 separate pieces. I'm going to rewrite 2x plus 1 as 2 times x plus 1/2. Okay, so I just factored out the 2, and you can verify if you distributed, you get that. Okay, and what we're going to do is we're going to divide separately. So we're going to start by dividing by x plus 1/2. And then once we get that answer, we'll divide by 2. Okay, so the logic here is it's similar to like if I wanted to do like, I don't know, 100 divided by 20, right? Obviously, we know that's 5. But you could also do 100 divided by 10, which is 10. And then do divided by 2, right? Divide that by 2, which is 5. So instead of dividing by 20, I divided by 2 things that multiply to 20, and you get the same answer, right? So you're just dividing it separately. All right, that's exactly what we're going to do here. All right, so we're going to set this up the same way that we've been doing. So coefficients on here, again, just double check. Make sure that you are not missing any. So no zeros necessary. All right, remember we're doing the opposite sign, so this is a positive 1/2, so I'm going to do -1/2. Okay, and then we're just following this process. So bring the first number down, so that's 2. -1/2 times 2 is -1, and then I add to get -4. Negative 1/2 times negative 4 is 2. Add to get negative 6. Negative 1/2 times negative 6 is 3. Add to get 7, which is my remainder. All right, so we're done with the synthetic division part, but remember, we have to divide by 2x plus 1, and so far I've just divided by the x plus 1/2. So now what we're going to do is we're going to divide by the 2. So what I'm going to do is I'm going to take all of these numbers and I'm going to divide it by 2. So these I'm dividing by 2 because there was a 2 here, right? Okay, and that's going to get me my final answer. So my final answer, 2 divided by 2 is 1x squared. It's 1 lower than that. Negative 4 divided by 2 is negative 2x. Negative 6 divided by 2 is negative 3. The remainder you do not divide by 2. Okay, so you leave that as 2x plus 1. We're saying this is what's left over after you finish dividing by everything else. Okay, so we still have 7 left over. All right, so let's try that again with this next one. So I'm going to do the same thing here. So I'm going to factor out that 3 and make that x minus 1/3. Okay, then I'm going to use my coefficients. Make sure there's no missing terms. So 3, 14, negative 11, 2. All right, I'm going to start by dividing by opposite sign, so it'll be 1/3. Okay, the 3 comes down. 1/3 times 3 is 1. That adds to 15. 1/3 of 15 is 5. Okay, that adds to negative 6. And 1/3 of negative 6 is negative 2, which leaves me with 0. Okay, and then remember, 0 is my remainder. So with this guy, side note, if your remainder is 0, that means that it's a factor, right? So I know that because my remainder here is 0, this polynomial evenly divides by 3x minus 1. If you factored this, that would be one of your factors. Okay, all right, and then one more step here, right? So then I've divided by the x minus 1/3, but we haven't divided by the 3. So I have to divide this by 3. And that's going to give me my final answer. One exponent lower, so it's going to be 3 divided by 3 is 1x squared plus 5x minus 2. And then the remainder is just 0, so that's it. That's my full answer. No need to write a fraction for 0. Okay? Hint with these ones, whenever you're dealing with the ones with the fractions, it should work out nicely. Okay, if you end up, like when you're doing this, if you end up with a fraction or something somewhere, go back and double check you probably did something wrong. Okay, so it should always pretty much work out that when you multiply by your fraction that you end up with a whole number. Okay, yeah, so just make sure that you double check that part because that's a good check-in. All right, these last ones, these ones tend to throw people off, okay? So make sure that you really pay close attention while we go over this one because this is one of the big stumbling blocks and one of the things that people get wrong the most when it comes to assessments, okay? So we are going to find a value of k so that this is a factor of this guy, okay? So remember, we just said that when you have a remainder of 0, that's what makes it a factor, right? Having a remainder of 0 is what tells you that something's a factor of something else, okay? So that's the first piece of information that we have here. Okay, so we know that if it's a factor, that means that the remainder has to equal 0. Okay, that is a known piece of information. Okay, so knowing that, we're going to use that to our advantage. Okay, I'm going to set up with a synthetic division just like we've been doing, and I'm going to include k as one of my coefficients. So no missing terms, but I'm going to do 2, 3, k, my unknown, 15. All right, and I know that I'm dividing this by positive 3, right? Opposite sign, remember. All right, and we're going to do our synthetic division, and I'm just going to roll with the fact that there's a k here. All right, and the one other thing that I forgot to write in is that because I know my remainder is 0, I know this number should equal 0. Okay, so that tells me that that should be a 0 there. All right, and now we're just going to roll with our synthetic division like we've been doing. Okay, so bring down the first number. 2 times 3 is 6. Add, so that adds to 9. 3 times 9 is 27. And then here, these guys aren't like terms, so I'm just going to write that as k plus 27. Okay, and then 3 times k plus 27 is going to be a distributive property. So that's 3k plus 3 times 27 is 81. Okay? All right, and I know that my last step would be I'd add these two together, and I know that the answer is going to be 0 because it's a remainder, right? So what this leaves me is it leaves me with this little equation that I can then solve. So I can look at this and say when I do 15 plus 3k plus 81, the answer should be 0. Okay, and then that's a pretty easy solve. So that's 3k plus 96 equals 0, so 3k equals negative 96. K would be negative 32. So that is the value that if you plugged it into this equation, it would make this perfectly a factor. Okay, so the trick here was recognizing that because it's a factor, I know what the remainder is. Okay, you could have also done this if they had said, instead of saying it's a factor, if they said the remainder was like 5, then you would know that there should be a 5 here. And then I just did synthetic division with some variables until I got to the last step and set up an equation from there. Okay, so make sure you practice those ones. Like I said, this is the most commonly messed up thing. All right, but synthetic division you're going to like. Okay, synthetic division is the thing people do really well with. It's fast, it's easy, it's kind of a nice little process that you follow.